Okay, this is the polar coordinate notes. In this unit, you will learn about polar coordinates. The polar coordinate system is especially useful in the modeling circular motion. Instead of x and y in the Cartesian or rectangular system, we will graph in terms of r, which is your radius, and theta, which is your angle measure. So if I give you a point, you're going to have r comma theta. Your r is going to be absolute value, and this is going to be the distance from the pole. And your pole is going to be your origin. I guess I could put that in. Okay, your theta is going to be the rotation from your x-axis. And I would say this is your initial side, so it's always going to be your 0. Okay, so when we plot these, you're always going to plot your angle first. Okay, so when I go ahead and plot 135, start from your initial side, go around and find 135. So this is 135 right here. Then from your origin, go out 3 units. So out 3 units would be right here. And this is your R. It's backwards from what you're used to. Next, you're going to do your S. We're going to do negative 120, starting from 0, negative 120. So this is 90. This would be negative 120 right here. Then we're going to go out 2 units. Out 2 units is right here. And this would be your S. Okay, your T, if we want to do 150, so go around 150. Now it says to do negative. So in order to do negative, you're going to go across your pole, which is across your origin, staying on 150, and go 2 units out. So we're actually on the 330 line, and this is T. U says do 60, so up 60 units, and then again it says negative, so go across 60, and it looks like it's on this line. Nope, it's on this line right here, which is 240, and 1 unit out. And this is your U. Okay, so this is going to be in radians, and if you notice, I left it blank. And if you want to take a minute and fill in your radians, please do so. You can pause it, the video. This first line right here and the lines closest to your origins will not be labeled. So you can go ahead and pause the video really quick and label this. Okay, so now that we have everything labeled, now we're going to do the same thing. You're going to do your theta or your radians first. And then you're going to graph this second. This is your R value. That always goes second. So do 3 pi over 2. So 3 pi over 2 is down here. And then I'm going to do out 2 units from my pole. So out 2 units would be right here. And this would be my A value. Negative pi over 2. And then opposite of the pole value. So negative pi over 2 is again here. 2 units of the opposite would be here. This is B. Negative pi over 6 would be, negative pi over 6 is actually here, and then 1 unit out is C. D is 7 pi over 6, so 7 pi over 6 is here. 3 units out is here. This is D. This should be an E. E is 7 pi over 4. 7 pi over 4 is over here, and then opposite, 3 units out over here would be E. Okay, it says name 3 other polar coordinates that represent point P. So I'm going to plot point P first and find 3 other coordinates that match this. So the first one I would do is go in a positive direction around here to 11 pi over 6 and then jump on the opposite R to be on top. So if we said 11 pi over 6, and then jumping opposite would give you a negative 2, and you'd be on point P. If you start at the origin, and you know what, if you start on 0 and go all the way around here, that's going to be negative 7 pi over 6, and you'll land right on point P. So that would be 2. Also, if you go a negative direction and start here and jump over, you would be on point P. So that would be negative 11, just pi over 6 and negative 2. and all of these points end up on point P. Okay, now it says converting between Cartesian, which is your XY, that's the one we're used to, and polar, which is always R comma theta. And we always graph polar in the opposite direction. It says convert 4 comma 7 pi over 6 to rectangular form, and it says find the exact values. Okay, so the first thing that I would do is go ahead and plot this how we know how to plot it. So this is our R comma theta, because we're going to rectangular, and rectangular, remember, is XY. So we want to go to that form. So how we plot this is I'm going to plot the 7 pi over 6. And 7 pi over 6 is over here in this quadrant. So this is about where 7 pi over 6 is. And remember, R is your radius, so I'm going to put that right there. So I do not know my X, and I do not know my Y. Okay? All right. So if this is a 7 pi over 6, then this is going to be a 30-degree triangle. So what I need to do is I'm going to find cosine and sine of this triangle so that I can find these values. So if I find cosine of 30 degrees, cosine is going to be x over 4. So if I solve for x, that gives me x equals 4 cosine of 30 degrees. Okay, we know the values if we set this up, and those are the ratio values. So this would be x equals 4 times cosine would be negative root 3 over 2. Simplified, x is going to be negative 2 root 3. Do the same thing for y, so now I know what x value is. So I'm going to do sine of 30, and that's going to be y over 4. So y is going to be equal to 4 sine of 30 degrees. So y is equal to 4 times negative 1/2. So y is equal to negative 2. I now know my xy, or I have got it back into a normal Cartesian or rectangular form. So it's negative 2 root 3 comma negative 2. Okay, now let's convert to radians. So this is your x and this is your y. It says convert this to polar. So if I want to go to polar, I want to end up in r comma theta. So I know this right here, negative 3, 4. So I'm going to go out negative 3 units and up 4 units. So this is negative 3 and this is 4. So that means this is 5. Since this right here is on this line, this is my r value, which is really easy. I'm glad I already have that. If we did not have this value, then you could find it by using Pythagorean theorem by saying negative 3 squared plus 4 squared is equal to your r squared. But we already know it because it's a special right, so I'm going to go ahead and say r is 5. Okay, in order to find my theta, I can do that by using tangent because I've got opposite and adjacent. So I'm going to say tangent of theta is equal to opposite over adjacent. And so theta is equal to arctan. Okay, way back when we were talking about this, and we were talking about if you drop your negative, anytime you drop your negative, it's going to save you a lot of work, and that's what I just did. So I didn't make a mistake. I did that on purpose. Okay, so the arctan of negative 4 over positive 4/3. Now you can't do this in your head, so you can pull out your calculator and use that. And that is going to give you an about number, and that's 0.927. Okay, that gives me this angle, and since it's over here, that's not going to help me out at all. This is basically just an angle. So I need to find my reference angle. So you're going to have to say pi minus the 0.927. And that's going to give you another about answer, and that's 2.214. And so that's what I'm actually looking for. So your r is 5, and your theta is 2.214. Remember, you're always using your reference angles, okay? Let me write that down. Always use reference angle. Okay, some of these formulas that I used are right here on this page right now, and you're more than welcome to memorize this. It's on your notes. if you don't like to memorize and use brain power, which I totally don't like to, it was very easy to figure out I needed to use cosine and arctan. So you're more than welcome to memorize if you want to. Okay, now right now it says to convert to polar from radians. So right now we have an x and we have a y value. So we're going to do the same thing that we just did. I'm going to plot 3, -5. So this is over 3 down -5. So I have to have a theta. I'm going to radians. I'm going to polar. So I need an r and I need a theta. So I need this value right here. So do Pythagorean really quick. To get my r value, so what is r going to be? And that's going to be √34. And in order to get theta, we use tangent. Tangent of theta is equal to 5/3. So tangent, theta is equal to arctan of 5/3. And again, if you want to jump to just this step and forget this one, you're more than welcome to. We don't know this, so you can use your calculator to find an about answer. And so this answer is 1.030. Since this is in the fourth quadrant, we're going to have to subtract to find an exact answer or our reference angle. So we're going to use 2 pi and subtract this given angle, or the angle we found. And that's going to be about 5.253. So writing your answers in r comma theta, your r is √34. Your theta is about 5.253. Okay, I'm going to give you the answer to number 2, and I want you to try to find it. It's not going to do you any good if you don't try it, though. I found the answer to be 2 pi over 3. And again, if you don't try this, it's not going to do you any good. Okay, and I will be checking in class to see if you actually did it. Okay, let's convert to rectangular form. So let's go ahead and plot 7 pi over 6 and 2. So remember, this is your radius and this is your theta. So 7 pi over 6 is in this quadrant and your radius is 2, we know. If it's a 7 pi over 6, it's a 30-degree angle. We don't know our x and we don't know our y. So let's go ahead and figure out our equations. If you want to look back at the page before, or you look at your notes, you can see that box and it tells you to convert to rectangular form. A shortcut, if you want to memorize, says take your x, if you know what x is, set that equal to the r times cosine, and take your y, define your y, and do r times sine. And that's what I'm going to shortcut and go ahead and do right now. If you don't want to, you can go ahead and say cosine of 30 degrees is equal to, cosine is adjacent over opposite, which would give you x over 2, which would in turn give you 2 times cosine of 30 degrees, which is exactly what x says. Take your r and multiply it times cosine of 30 degrees. So go ahead and use cosine, or you could memorize kind of a shortcut. That's totally up to you. Okay, so what I found my x value to be is -√3. Do the same thing with sine. So sine of 30 degrees is y over 2. So that's going to be y is equal to 2 times sine of 30 degrees, and I found my y value to be -1. So x comma y is my new ordered pair, and this is in the Cartesian or rectangular form. Again, I'm going to give the answer to this one, and I want you to go through and try to find it. I found my x value to be 5/2 and my y value to be 5. I see -5√3 over 2. And I really want to see y'all work this out. Okay, so there's a bunch of problems here, but they're really short. You can go back to that box that has some shortcuts in it. So what we're going to do is it says write the equation in polar. So polar means that I want r's and I want thetas. So this is what I would probably do with this one. Okay, look, we just use this a lot. What is x equivalent to? And I just used it in the problem. If I know what x is equivalent to, I can replace it. So x is equivalent to r cosine theta. So I'm going to replace my x with r cosine theta, and I'm not worried about the 7 because my whole point is I want r's and I want thetas, which I just did. So I'm going to solve for r, and so r is equal to 7 over cosine of theta, and you're done. You have r's and you have thetas, so it's in polar form. Okay, look at the number 6. Again, I want this in polar form, so I only want r's and I only want thetas. So is there anything that we know? I got to get rid of my x's and my y's. On the conversion sheet, in that box, it says that r is equal to the square root of x squared plus y squared. So that means that x squared plus y squared is r squared. I'm going to write that down. If we know this, then r squared is equal to x squared plus y squared. So that's what I'm using here. So you could leave it in this form because I have an r. I don't have a theta, which is totally fine. Or you could go ahead and say that r is equal to 4, and that could be your final answer. Okay, number 7. Now I want to go to rectangular form. So that means I want x's and y's. Okay, what is r equivalent to? Well, I wrote it up here. R is equivalent to this mess. So if r is equivalent to the square root of x squared plus y squared, let's replace it. So I'm going to say the square root of x squared plus y squared, that's equal to -3. Okay, how about we square everything? So I'm going to square this, and I'm going to square this. That gives me x squared plus y squared, and that's equal to 9. And you can leave it just like that, and you can be done. You don't have to solve for y. It's just getting rid of your r's and your thetas. Okay, again, I want x's and y's. So what do we know about theta? Well, the only thing that they told us about theta is tangent. Okay, I'm going to do something weird here. All I'm going to do here is I'm going to multiply by tangent. Okay, so that's going to give me a tangent of theta, and that's going to give me a tangent of -pi/3. Okay, so what is tangent of theta equal to? Well, what we were doing in the previous problems is we know tangent of theta is equal to y over x, which is awesome. We got rid of our theta. So what is tangent of -pi/3? Well, if you need to draw your triangle of tangent of -pi/3, make sure you do so. That's down here. That's going to be a 60-degree triangle. That would give you -√3. Okay, you could leave it like this. It looks kind of crazy. I'm going to go ahead and solve for y because I think this looks silly. So I'm going to say y equals -√3x. Let's see what to do with this one. Okay, we're going to rectangular again. So xy. Okay, just like before, I multiplied by tangent. There's nothing with secant in it. So secant is the reciprocal, or cosecant is the reciprocal of sine. So I'm going to multiply by sine theta. Okay, if I do that, and you're going to, this comes out pretty cool. This gives me r sine theta, and this gives me -5 cosecant of theta times sine theta. Okay, this one right here, r sine theta, is y. And if you remember your stuff, this times this cancels, and you have -5, and we're done. All right. Okay, these last two problems is basically the same thing we've been doing. It's just set up a little bit different. The figure below shows baseball diamond placed in a rectangular coordinate. So this is your x, this is your y. The coordinates based on a second base. They're 90 feet apart. Find the polar coordinate. So we're going to polar. So this is 90 and this is 90. 90, 90. Here's your triangle. We need to find R. So we're going to R. We need to find our R and we need to find our theta, just like we've been doing. Okay, so you need to do Pythagorean and find this. Okay, you're going to have to do it in your calculator. It is a rounded number. So 90 squared plus 90 squared is equal to R squared. I found R to be in about 127.279. Okay, in order to find theta, remember theta is equal to, by now you should know, arctan of 90 over 90, which is 1. Okay, so arctan of 1. So if we draw that triangle, I'm going to go ahead and draw that for you people. That's 1 over 1, which is root 2. So what angle is that going to be? That should be pi over 4. So my answer is my R first, which is 127.279, and my theta, which is second, is pi over 4. And there's my answer. Okay, example 7 is a basketball court. The figure below shows a basketball court placed on a rectangular coordinate plane. Find a polar coordinate for the player at point A. Okay, so for this one, it's in quadrant 4. This would be 15, and this would be -6. Okay, so you need to do Pythagorean to find your R value. And this R value I found to be about 16.155. To find your angle, we're going to do arctan. So theta is equal to arctan of